Azure is worldwide, and we've talked about the ability to fire up a web server, like an app service with the websites, and spin them all across the globes. They're all collaborating, and you have websites right next to the people who are browsing those websites for very high performance. That can be dramatic overkill if all you're trying to do is serve up images, videos, and other types of content, text content as well, up close to them. And what the internet has evolved to do is use something called a content delivery network. And the content delivery network allows us to take our core assets and distribute them out across the internet on edge nodes so people can get to them very, very rapidly. Like many other services, Azure has this as a core service, and I want to talk a little bit about it. And there's 3 core elements on the slide that might be worth looking at. You've got your origin server. Now, instead of having to take that origin server and put it at 20 different data centers, you have one origin server that might be sufficient, and you keep it local to US West or somewhere else. You keep it local there, and then when you're serving out your web pages and whatnot, you register with Microsoft's Content Delivery Network, that CDN. And that CDN then allows people who are accessing it via HTTP to very rapidly get portions of your website, web page, API, whatever those things are, served up to them very, very rapidly. So a couple CDN scenarios, if you take a look at the slide. Streaming media is a big one. If you have customer-facing websites, especially if you're globally distributed, you might have enterprise apps that are hosted in the cloud that you want performance worldwide. Software application downloads and updates, right? Windows updates don't come from Redmond, right? They come from the CDNs across the world. Firmware updates, dataware, there's so many different wonderful uses. Now I'm going to go right to the next slide where we talk about the CDN traffic flow, just to give you an idea. You look in and find out more, but the idea behind it is the very first request that comes from the client, well, it goes through the CDN edge network that says, hey, I don't have it. I don't have the latest. Caching kind of feel to it, right? We get where we're going. And it returns it, and the next time the client requests it, it stops right at the edge network because it's already there. Think of it as a globally distributed caching system, and you can kind of get a feel for CDN. And again, this is a very short presentation just to get your mind around CDN, what content delivery networks are, and we're going to be moving on from here, but think about CDNs when you need to widely distribute some of your assets and you don't want to build multiple websites hosted in different data centers.
All right, so here I am in the Azure portal, and what I want to do is spin up a cluster of machines that I can use to host containers. And so that's pretty easy to do. I don't have to go through and do my individual resources. I can just come into the Azure Marketplace and search for container. And here is the Azure Container Service, and it'll give me some information about the Azure Container Services, and I'll just hit create, and that'll open up the wizard to help guide me through creating the cluster for my Azure Container Services. So I'm going to give myself a username. I'll just use Colin, and then I've created an SSH public key, and we'll paste that in there. So the reason we want this is because we want to be able to access the container services in a secure manner, and so SSH is a well-established secure platform and protocol for connecting to services, and so we can use that. I'm going to choose a subscription, and this is going to create a new resource group for me so that all the resources for this container service are in a single resource group. So I'll just prefix this with my initials, and we'll call this container service. We'll choose a location. Container services isn't available in all locations, but it is available in West US. Now for the orchestrator configuration, I'm going to choose from one of 3 orchestration methods. DCOS, which is built on Marathon and Mesosphere. There's also Kubernetes or Swarm. So these are other orchestration mechanisms that I can use. And so we're going to choose the one that we want to use for managing the orchestration. So I'll choose DCOS. And here's where we can configure how many agents there are in our cluster. For this demonstration, I'll just use an agent count of 1, but you can, of course, choose however many agent machines you want in the cluster. These machines will be aggregated together and will be accessible as if they're a single machine. And that's one of the advantages of container services, is that it lumps together all these resources and makes it look like a single machine. We can also choose the virtual machine size. So if I click on that, we'll get to choose the size of agent machines that we want, and we'll just leave it on DS2 standard, and that's the size of machines we want. And then we can select how many masters we want, and then we have to give it a DNS prefix for the container service. So I'm going to do cd container, and Azure will go and check if that DNS prefix is available. So that's the prefix that I'll use to get to the management machine, as well as to the publicly accessible ports that Azure sets up when we create the container services. Alright, so we'll select that. I'm not going to enable VM diagnostics. We could enable that to run diagnostics, so that if we have issues on the agent machines, we can connect to the logs and diagnose any issues that we have. So we'll get this summary page. We can see the validation is passed. If we download the template, this will give us the Azure Resource JSON file, and we'd be able to then use that file and spin this resource group up without having to go through the wizard again. We can then also parameterize that, so we can deploy multiple instances of this container service from the same template. We're just going to skip that now and say OK. This will give us the final confirmation page and the terms of use, and we'll hit purchase, and that'll go and spin up that resource group. So this will take a couple of seconds. I'm going to fast forward the video and we can get started with the container service. So here I am back in the portal, and the container service has been spun up in Azure, and this is the blade for the resource group. And so you can see there's a ton of resources that get created for you. There's a bunch of storage accounts, there's the container service itself, there's a couple of public IP addresses, there's load balancers, there's virtual machine scale sets, there's network security groups, and so on. So there's a bunch of resources that get created for you, and these are all managed for you behind the scenes. So you just tell it how many machines you want, as we did through the UI, and Azure takes care of all the load balancing and running of those resources while your containers are running in the container service. So in order to interact with this container service, we're going to need to connect to the management machine. So I'm going to look for the master IP. So this is the DNS and IP address that's assigned to the master machine. So here's the DNS name. So I'm going to copy that out into the clipboard, and I'm going to come over to my Windows Bash terminal. And this could be run through any terminal, really. It's any terminal that can run SSH. And I'm going to run an SSH tunnel. So here is the SSH command that I'm going to need to run. So I'm mapping port 88 on my local host to port 80 on the management host, and I'm connecting using :@, and then I'm just going to paste the management IP address, and I'm connecting on port 2200, and I'm now also adding my private key. Remember, when we set up the container service, we gave Azure the public key, and so this is the corresponding private key, and this is what makes that tunnel secure. So I'm going to run that. It's going to ask me for a password for sudo, and I'm going to add this to my trusted hosts, and then I've got a passphrase for my SSH key, and now that tunnel is established. So what that means is that I can access port 88 on my local machine, and that will tunnel through to port 80 on the management server. So let's open up port 88 on my local host, and this takes me to the DCOS management page, and this is where I can see my cluster, and this gives me a view of the cluster as if it was a single machine. So I can use all the memory, I can use all of the disk space and so on, essentially as if it was a single machine. So this view is not particularly interesting at the moment. There's nothing running, and so what I want to do is I want to spin up a demo application, and what I want to do is actually spin up the DCOS website. There's a container for the DCOS website, so let's go to Docker Hub, and I'll search for DCOS website. And here's the image that contains the DCOS website. So I want to get this spun up and I want to load balance it over 3 instances within my container service. I'm not talking about how we get the image into our repository, in this case Docker Hub, in the first place. That'll be part of the discussion around DevOps. But you can imagine that you have a CI/CD process that is building your container images and publishing that image to either Docker Hub or some private Docker repository. And so you're now wanting to take an instance of that image or multiple instances of that image and actually run it in the container service. So we'll just use this for the demo, but of course this could be any of your own containers. So in order to do that, I'm going to install a Marathon load balancer. And so I'm going to use Universe, which is kind of like a marketplace for DCOS components and services. And I'll search here for Marathon load balancer. So we'll click on the Marathon load balancer, and this gives me some information about the Marathon load balancer, but we'll just click install package. Now, because I have such a small pool of agents, I'm going to have to go to advanced installation and just take CPUs down to 1 and take the amount of memory down to 256. Otherwise, I wouldn't really have to edit anything here, so I'm just going to take all of the defaults. Of course, you can go and tweak this installation according to your particular scenario. So I'll hit review and install, and once I hit install, that's going to install that service. So it says success. If we go over to services, we can see that it's deploying that Marathon load balancer container. So it's pulling that container down and then it's going to deploy it. And the way that DCOS works is that components that come out of Universe have a JSON manifest file that describes how that service should run. And so this is what we're seeing here. It's now running and we have the service available. Now, in order to run the DCOS website, I'm actually going to open up a JSON file. Let me go back to my bash command prompt and I'm going to go into the DCOS folder, and let me just cat the DCOS demo JSON file. And so let's have a look quickly what's in this file. We have the name of the component is going to be DCOS website. We're telling it it's of the Docker type. We're telling it where to get the image from, so we're using a specific label of that image within Docker. And then we're setting up some other properties, like we're telling the network mode is bridge. We're opening up port 80 on the container, and that's mapped to a particular service port. Then over here we're telling it DCOS that we want 3 instances of this container. We want 0.25 of CPU for each of these containers. Each container is going to have 100 megabytes of memory assigned to it. And then down in labels here, I'm going to make sure that the IP address that's exposed here is the IP address of the public agent in my Azure Container Service. So let's go back to the portal window and find out what the IP address is for the agents. And here I have the public agent. This is the public agent IP address. And so again, I'm going to copy that DNS name. Azure Container Service will expose particular ports on this one. 80 is one of the ports that's exposed by default on the public agent. You can of course go in and change that in the resource group if you need to. So let's go back to that JSON file and make sure that we have the right proxy host. So I'm just going to edit that file in Nano. And we will come and make sure that the host is the correct IP address. And now that we have that JSON file, we can actually use the DCOS CLI to interact with our container service. So the DCOS CLI lets me interact with that Azure Container DCOS service. And you can see that there's extensions like Marathon, which is one of the services, and Marathon is used to install new applications, for example. So I'm going to use DCOS Marathon, and I'm going to call the app command, and I'm going to add an app, and I'm going to use the DCOS demo JSON file that we just looked at as the manifest for that application. And that's created a deployment. So if we go back to the user interface here, and you can see that it's deploying 3 instances, deploying 0 of 3 for that website, and this will take a couple of seconds. And we can see that service is now running. If we click on that service, we get some details. We can see each of the containers that's running that image, and they're all reporting a healthy status. And if we go back to the dashboard, we can now see how much of our resources we're consuming with all of the containers and services that we have running currently. So let's go and look at the application. So I'm going to open up another tab and we'll go to the public port. Now I haven't configured the certificate, so I'm not going to worry about that. We'll just proceed, and now we have an application that's running. It's load balanced across 3 containers within our container service, and it's just working. So this is great in terms of running package services, in terms of creating manifests to run our own applications, and it's all managed under container services for us, spreading that load over the machines that we give it, so we're getting as much scale as we need without having to worry about putting containers on particular nodes within the cluster. So Azure Container Services is abstracting all of that away for us. And that's Azure Container Services.